Welcome back, guys. Today I want to talk about a typical foundation, the kind of foundations that we do on a daily basis. So first off, a couple of disclaimers. Foundation I'm about to show you is a digital foundation that is assumed to be on good ground. So if you're going to do this, then you must have determined that your ground is good ground. Otherwise, best if you consult your geotech engineer and structure engineer for a specifically designed foundation if your ground is not considered good ground as per the standards NZS 3604. I'm just going to turn around the camera and then I'll show you sort of what is considered a typical foundation as per good ground. So here we are, and what you see there, so this one here is one that I normally use. I drew this one, I use this one sometimes. I'm calling it it's a perimeter foundation with block work. So what happens is that I just want to take you through the elements. So what you have here is your footing. So normally we assume a footing of 300 wide by 200 deep. And that will run all around your perimeter. That's why it's called a perimeter foundation. And then we are using block work. So this will be about 25 or 20 series block work or 200 series block work. So that means it's about 200 thick solid field masonry block work. And then we use two of them. So that's the first one there. And then the second block, we normally cut it into half, cut this part into half, and then when you pour your slab, so the slab will come in and join the rest of the block there. And then of course the slab, typical slab is normally be 100 mils thick with specified mesh as per the structure engineer. The common mesh that we use is about 500E, and that has different types. It could be S62, S72, or any other depending on the structure engineer specifications. And then on top of the slab, you will have your, so inside the slab, you'll have your mesh. That is mesh, about, I think, 30, embedded about 35 mils. And then the most important thing that we do nowadays, or since the Christchurch earthquake, is to tie the slab together with the foundation. So you see this one here, this is these are D12 bars. So these are D12 bars, and they'll run through the slab, and then they will come down, and then they're tied into the footing as well. So through the masonry block and into the footing. So you have your D12 there horizontal and then into the slab. I think in my last video where we were inspecting a typical foundation, I was able to show you something similar. And then of course you have your waterproofing around, these are waterproof membrane around the foundation. So this prevents any water ingress from this side, and under the slab you'll have waterproofing. Again, nowadays, because of H1 requirements or thermal efficiency requirements and the need to create energy efficient houses, we normally have insulation. We'll have some form of insulation under the slab. I'm trying to find something that symbolizes insulation here. We'll probably just use rigid insulation. Or just use any, I'll probably just use, yeah, there you go, styrofoam. So sometimes you might add beneath the slab, you might go with some bit of insulation there, and then that one will come down. Like that. So the series of see your knot will be perimeter foundation to be 200 series solid fill masonry block work on 300 by 200 millimeter deep footing with 3 D12 reinforcing bars, and then you have your D10 ties at 600 centers lapped into the floor slab 600 millimeter into the floor slab at 600 millimeter centers. So this one is lapped into the thing at 600 centers, and then you've got your insulation, and then your sun blinding, and then your hardcore. This will be your hardcore down there, or engineering fill, and then your insulation will come right up to the finished ground level. Then another critical thing is so here if you're using, say, like weatherboard cladding, these are like linear weatherboard cladding, they will have to drop down the foundation at least 50 mil below the slab level, at least 50 mil, like that. And then this distance from top of the slab to unpaved ground normally is 225 millimeter clear. Or if you have this as paved, if this was paved, then this will just be maybe 150. So from there, it will probably be 150 to paved ground. Let's see if that will work. Dark details. Let's see if I can make that shift 150. So to paved ground, that will be about 150. And I'll just say here to paved ground. Let's just use paved ground, yeah. Text is a bit. Now we just probably make that one. Actually, one won't be readable. Maybe make it 1.8 or even 2. Yeah. So that will be 150 to paved ground or 225 to unpaved ground. And of course, your walling, I'll talk briefly about the wall. So anytime you have timber connecting to concrete, you must have DPM. Okay, so we normally put DPM between the bottom plate and the timber. This is to prevent moisture from egressing into the timber. Then you have your timber framing, which is 90 by 45, but nowadays sometimes it's actually advisable to do 145 by 45 timber studs. Just they they basically increase your thermal they basically increase your thermal capacity, energy efficiency, because then you can use larger insulation, thus increasing the energy efficiency of the house. And then of course you have, if you're using weatherboard, then you're gonna have that gap there as 20 mils. That's your cavity battens. So about 20 mils. And then that one there will be your building wall underlay, which is a vapor barrier. And again, sometimes nowadays you can use like James Hardy have what is called 6 mil rigid board, RAB, rigid air barrier. So instead of underlay, you could use a rigid air barrier, and then you have your cavity, and then you have your weatherboards there, nailed there. So this one helps to for moisture egress and drying up the making sure your wall is constantly dry. Yeah, so basically that is what you have. I have for a typical foundation on good ground. I must emphasize this has to be on good ground. Otherwise, if it's an expansive soil or any other different type of soil, you will need first of all a geotech report to determine the type of foundation that will be done, and then an engineer can then design, a structure engineer can then design one for you. Now on this other side, I have same type of foundation, but now using brick veneer, and there's a slight difference when you're using brick veneer as cladding. Of course, again, assuming good ground, 300 wide by 200 deep, and then we are all tying it with the slab. And this time around, we've got a recess the slab. We have to do a rivet on the foundation so that we have our brick veneer sitting there. And then this is 70 millimeter brick veneer, 70 series brick veneer, which is tied to the wall, which is normally tied to the wall framing. And then of course insulation, building paper. Other difference with this one is that the cavity for brick veneer is normally 40 to 50 millimeter cavity, and then every third parapet, every third block, or every third brick, you gotta have whip holes, just so that the brick, you can allow for expansion and construction and also moisture ingress within the brick. But this detail follows the same as in terms of foundation, the detail is more or less the same. So basically, I promised I would show you, I'll talk about a typical foundation in New Zealand. And you can take this and adapt it to your situation. Just make sure that you talk to a structural engineer and a geotech person if you want to adapt this sort of foundation. But this is what we use in New Zealand typically as foundation. As Otex green, this insulation that we put into the framing to help with the with energy efficiency and thermal insulation. So yeah, guys, there you have it. Two types of foundations, similar foundation, but using two different types of brick of cladding. Using different types of cladding, wall cladding material, that is brick veneer and linear weatherboard. So yeah, that's what I promised to talk to you about. I was just finishing off my day today, so I thought I should do a quick video on showing you how we design, how you can design a foundation, or how you can detail a foundation basically. And this is what I used to teach students back then. So if you like this video and you like anything more alongside, I mean anything to do with construction and stuff, please hit the subscribe button below, share and like, and I will see you in the next video.